Mr. Chairman and members, thank you for inviting me to present highlights from our recent report about climate change impacts on transportation in the Central Gulf Coast region. This work was led by the U.S. Department of Transportation and is one of the 21 synthesis products of the U.S. Climate Change Science Program. The other co-leads for the project, Mike Savanis behind me from DOT and Joanne Ponder as well from Cambridge Systematics, are here with me today. The region between Mobile, Alabama and Galveston, Texas contains the largest concentration of U.S. ports and thousands of miles of pipelines and onshore infrastructure like tank batteries and processing plants that receive and transport 2/3 of the United States oil imports and more than 90% of our outer continental shelf oil and gas. These facilities, plus 17,000 miles of highways and 61 airports, are all vulnerable in some way to climate change that is anticipated during the next 50 to 100 years. The four primary drivers are accelerated sea level rise, increased air and water temperature, an increase in the intensity of tropical storms, and changes in rainfall patterns. An acceleration of sea level rise is due to thermal expansion, the heating of the water, and the melting of glaciers and ice sheets is one of the most certain and most costly consequences of global warming. This region has very little topographic relief and is highly vulnerable to permanent flooding due to subsidence and or accelerated sea level rise, and in fact, both of these are occurring, sea level rise and subsidence. From Mobile all the way over to Galveston, this is very common. As the temperature of the sea surface increases, tropical storms are likely to intensify. This coastline is vulnerable to flooding, erosion, and wetland loss during tropical storms. As barrier islands and mainland shorelines erode, human communities and onshore infrastructure in low-lying coastal areas become more susceptible to inundation and destruction. Climate models indicate an increase in average temperature of the region and extreme high temperatures. Rainfall is expected to come more in the form of heavy downpours, with an increase in the spacing between rainfall events. All of these changes in the physical climate can directly affect transportation infrastructure and the physical stability of the coast upon which the infrastructure sits. Warmer temperatures may require changes in materials, maintenance, and operation of transportation systems. Some pavements deteriorate more quickly. Rail lines will buckle. Higher temperatures affect the length of runways and aircraft performance. More intense rainfall would increase the short-term flooding of roads, which is already a problem in the region. We learned from Hurricane Katrina that prolonged flooding can damage pavement infrastructure. With a storm surge of 23 feet, and we had 30 feet in the area during Katrina, but with 23 feet, 64% of the interstates, half of the rail, 29 airports, and all of the present port facilities are subject to flooding. Even if storms do not increase in intensity, existing infrastructure will be more likely to flood as sea level rises. While protective structures like levees and seawalls can protect some facilities, flooding of even small segments of a road can make the entire system unusable, which is important in terms of hurricane evacuation. Thank you, sir, and we have experts from transportation that can help answer questions.